Welcome to our module on SQL for Business Analytics, where we will explore how to manage and analyze data. This course aims to help you master data interaction skills for making informed and strategic business decisions. Today, we will explore SQL and relational databases, fundamental tools in data management. Understanding these concepts is key to mastering the language of modern data management. First, let us look at SQL, which stands for Structured Query Language. SQL is primarily used to manage and manipulate information within relational databases. It allows us to query, insert, update, and delete individual data records efficiently. Furthermore, SQL defines and alters the overall structure of various databases. Now, let us consider what relational databases actually are. These databases are structured into tables, consisting of organized rows and columns. They store data in a highly efficient and easily accessible manner for retrieval. Relational databases are designed to link data from various different sources together. Today, we focus on SQL and its incredible ability to derive insights from data. SQL is a powerful tool for extracting meaningful insights from complex data sets. SQL excels at data retrieval, allowing us to pull specific information quickly. It helps you to quickly extract valuable insights from even the largest data sets. Data manipulation is another core strength of SQL, enabling data transformation. You can clean, filter, and transform raw data effectively for deeper analysis. SQL is also excellent for aggregating data, summarizing information efficiently. It can generate summary statistics such as sums, averages, and counts easily. Efficient querying is a hallmark of SQL, ensuring fast data access. This allows you to access specific data points rapidly, saving valuable time. Finally, SQL offers seamless integration with various BI tools. You can connect it with popular tools like Tableau and Power BI for visualizations. Today, we will compare relational and non-relational databases, two distinct storage structures. Understanding these data storage structures is crucial for choosing the right database solution. Let us begin by examining the characteristics of relational databases. Relational databases store data in highly structured tables with predefined schemas. They primarily use SQL, the structured query language, for data interaction. Common examples include MySQL and PostgreSQL, widely used in industry. Now, let us turn our attention to non-relational or NoSQL databases. Unlike relational databases, they do not rely on a strict table-based structure. Many non-relational databases may not natively support SQL for querying. Popular examples include MongoDB and Cassandra, designed for different data types. Today, we will explore the essential components that form an SQL database. Understanding these building blocks is key to effective data organization and management. First, we have tables, which are the fundamental components of any database. Tables are indeed the core components of every relational database system. They consist of rows representing records and columns, which are attributes. Importantly, each individual row within a table represents a unique record. Next, let us discuss schemas, which define the database's overall structure. A schema precisely defines the database structure, including all relationships. Think of it as the blueprint for how all the data is meticulously organized. Schemas encompass tables, views, indexes, and other database objects. Indexes are crucial for enhancing data retrieval performance in large databases. They significantly improve the speed at which data can be retrieved from tables. Indexes provide quick lookup capabilities, similar to an index in a book. They are essential for columns that are frequently accessed or used in searches. Views offer a simplified way to work with data, acting as virtual tables. Views are virtual tables derived from the results of stored SQL queries. They help simplify complex queries by presenting data in a more accessible format. You can interact with a view as if it were a single, physical table. Finally, we have stored procedures, which are pre-compiled SQL statements. These are predefined SQL queries that are stored directly within the database. They allow for the reuse of complex or frequently performed database operations. Stored procedures can significantly improve both database performance and security. Today, we will delve into the basic structure of SQL queries, starting with fundamentals. These fundamental clauses are essential for effectively extracting data from your databases. We begin with the select and from clauses, the core of any query. The select clause specifies which columns to retrieve and from indicates the table. This example retrieves first name and last name from the sales data table. Next, the where clause allows us to filter data based on specific conditions. It filters data based on specified conditions, effectively narrowing down your query results. This snippet shows how to filter results for data where the region is North America. Finally, the order by and limit clauses help organize and restrict results. Order by sorts the result set and limit restricts the number of returned records. This sorts by sales amount in descending order, then limits the output to 10 records. Today, we will explore key relational database concepts that structure and link data. Understanding these concepts is vital for structuring and linking data effectively for analysis. A primary key serves as a unique identifier for each record within a table. It ensures that every single record in a database table is uniquely identifiable. A foreign key is crucial for linking related tables and maintaining data integrity. It links tables together, ensuring referential integrity across your database. An inner join combines rows from two tables where there is a match in both. It specifically returns only those records that have matching values in both tables. A left join returns all records from the left table plus matched records from the right. This means you get all left table records and any matching records from the right. A full outer join retrieves all records when there is a match in either table. It returns all records from both tables, including non-matching ones where applicable. Today, we will cover advanced SQL filtering techniques for precise data selection. These techniques allow you to refine your data selection with greater precision and control. The between operator filters data that falls within a specified range of values. It allows you to select records where a value is within a defined lower and upper bound. The in operator helps match a column's value to several possible options. It is useful for filtering records where a column's value is among a list of specified values. The like operator filters data using pattern matching, often with wildcards. This allows you to search for patterns within text using characters like percentage and underscore. The is null or is not null conditions filter for empty or non-empty values. These operators are used to check for the presence or absence of a value in a column. Logical operators combine multiple conditions. They enable you to create complex filtering criteria by linking several and, or, and not conditions together. Today, we will explore how to aggregate and group data to summarize large data sets. These techniques are crucial for summarizing insights and making sense of vast amounts of data. First, let us look at counting the total number of records within a table. This SQL query counts the total number of customer IDs in the customers table. Next, we will sum values, grouping them by specific predefined categories. This query calculates the total sales amount for each region, grouping by region. Finally, we will learn to filter grouped data using the having clause. This SQL query counts customers by region, then filters for regions with over 50 customers. Welcome to our hands-on project, focusing on key SQL tasks for business analysis. This section will provide practical applications of SQL for effective business analysis. First, we will learn how to calculate the total revenue generated from all sales. This sums the revenue for all sales transactions occurring within a specific defined date range. This code uses sum to calculate total revenue from the sales table for the year 2024. Next, let us analyze customer spending patterns to identify our most valuable customers. This identifies top customers based on their total spending and the number of purchases over a period. This query joins sales and customer tables to find the top 5 customers by total revenue in 2024. Finally, we will calculate the gross profit margin, a crucial indicator of profitability. It determines profitability by subtracting the cost of goods sold from the total revenue generated. This SQL calculates gross profit margin by using revenue and product price multiplied by quantity for 2024. Okay, Let us now review the key takeaways from our discussion on SQL. Here are the essential points to remember to solidify your understanding of SQL. Remember, SQL is absolutely crucial for effectively managing and analyzing large datasets. It is important to master the basic query structure and fundamental SQL clauses. Advanced techniques such as joins and the having clause greatly refine your data analysis. SQL empowers you to calculate vital business metrics for informed decision making. Developing practical SQL skills will certainly drive better data-driven business decisions.